Problem 45, Quantum Mechanics. The question is, which of the following is a self-adjoint operator in the spherical polar coordinate system r, theta and phi? Four options are given. We have to choose the correct option. We know that any self-adjoint operator is Hermitian, and if the operator is Hermitian, we can write a dagger equal to A, and we can also have integral over all space phi star a psi d tau, that is equal to integral over all space within bracket a phi whole star psi d tau. We have to check all the four options in the question, and for convenience I am taking option C. Let us take A is equal to the operator A, which is equal to minus IH bar by sin theta dou by dou theta. Now, if the operator is Hermitian, then we can have integral over all space phi star a psi d tau. This is equal to integral over all space a phi star psi d tau. First, let us check what is integral over all space phi star a psi d tau. We can write it as integral r equal to 0 to infinity, integral phi is equal to 0 to 2 pi, integral theta is equal to 0 to pi, then phi star, what is A? Minus IH bar by sin theta dou by dou theta acting on psi, then d tau. In spherical polar coordinate system, we know that d tau is equal to r square dr sin theta d theta d phi. Therefore, integral over all space phi star a psi d tau, this is equal to integral r is equal to 0 to infinity, integral phi is equal to 0 to 2 pi, then we can write r square dr d phi, integral theta is equal to 0 to pi. Now, we have the sin theta in the numerator and the denominator will cancel, and the remaining term is minus IH bar, then phi star dou psi by dou theta into d theta. This is integral over all space phi star a psi d tau, where a is taken as minus IH bar by sin theta dou by dou theta. Let it be equation number 1. Now we have to evaluate the last integral, integral 0 to pi minus IH bar phi star dou psi by dou theta d theta. Take it as I. Now, this is equal to minus IH bar within bracket. After integration, you will get phi star psi. The limit of integration is from 0 to pi. Then minus integral from 0 to pi dou phi star by dou theta, then psi, then d theta from 0 to pi. Let us close the bracket. Now, what is the first term? We know that as theta tending to 0 or theta tending to pi, the wave function phi tends to 0 and also the wave function psi also tends to 0. Therefore, phi star psi within the limit from 0 to pi is equal to 0. Hence, our integral I becomes I is equal to IH bar integral 0 to pi dou phi star by dou theta, then psi d theta. Now we can write this integral I as I is equal to integral 0 to pi minus IH bar by sin theta dou phi by dou theta dou phi by dou theta whole conjugate, then sin theta psi d theta. We are multiplying and dividing by sin theta. Hence, our equation 1 gives integral over all space phi star a psi d tau, that is equal to integral r is equal to 0 to infinity, integral phi is equal to 0 to 2 pi, integral theta is equal to 0 to pi. Now we have minus IH bar by sin theta minus IH bar by sin theta dou phi by dou theta whole conjugate, then psi, then r square dr sin theta d theta d phi. Now let us look at the RHS. What is the first term inside the integral? This is nothing but a phi whole conjugate, and the last term is nothing but d tau. Hence, we can say our integral is nothing but integral over all space within bracket a phi whole conjugate psi d tau. Thus, we can say that the operator A minus IH bar by sin theta dou by dou theta is Hermitian. Therefore, it is the self-adjoint operator, and from the given option, we can say option C is the right option.